solving systems of equations with three variables. So to do this, what we're trying to find is an x, a y, and a z that when we plug it in will make all three equations true. So I'm looking for x, y, and z. To do this, there are a few steps. Step number one is to write all three equations with y by itself. So I'm going to write them with y by itself. So let's start off with equation 1, 2, and 3. How about equation 1? It's 4x minus y plus z equaling 0. We want to get y by itself, so I've got to get rid of the 4x. So I'm going to subtract 4x from both sides. That goes away. I have a negative y plus z equaling a negative 4x. Again, I still have z here, so I want to make it go away. So I'm going to subtract z from both sides. This is gone. A negative y equals a negative 4x minus z. Now, I'm really close to having y all by itself, but I have the negative 1. So I've got to divide through by a negative 1. This is gone. Over here, everything gets divided by the negative. So a negative 4 divided by a negative 1 is going to give me positive 4. Then a negative z divided by a negative 1 gives me a positive z. So I've taken equation number 1, solved it for y. So I'm going to go ahead and write it over here. So we've done equation 1. Now we have to do equation 2. It's negative 2x plus 2y plus 3z equaling 3. So again, I want to get y by itself. So I've got to move my 2x to the other side. So I'm going to go ahead and add it. This goes away. I'm left with 2y plus 3z equaling 2x plus 3. Now I still need y by itself, so I'm going to get rid of the 3z. So I'm going to subtract it from both sides. That goes away. Over here I'm left with 2y equaling 2x minus 3z plus 3. I'm really close to getting y by itself, but I still have that 2. Divide everything through by 2. We'll be left with y equaling 1x minus 3 halves z plus 3 halves. So now I've taken equation 2 and gotten y all by itself. So y equals x minus 3 over 2z, make that look like a better z, plus 3 over 2. So equation 1 and equation 2 are done. I still need to work on equation 3. It's a negative x plus 3y minus 2z equaling a negative 19. For this one, to get y by itself, I want to add x to both sides. This goes away. I have 3y minus 2z equaling x minus 19. Now again, I still have z here. So I want to add the 2z, since this is a minus 2. I'm going to add 2z to both sides. This goes away. I get 3y equaling x plus 2z minus 19. Again, we want y by itself, so I still have the 3. Let's go ahead and divide through by 3. This side will go away. I have y equaling, there's a 1 in front of this x, so this gives me 1 over 3. This is going to give me 2 over 3. And since it's negative, I'm going to get 19 over 3. So I've taken equation 3, I've solved it for y. So now I have y equaling 1/3 x plus 2/3 z minus 19/3. So now we're done with step 1. I've got all three equations written with y by itself. Now we're on step 2. to set equations 1 and 2 equal to each other. Then we're going to do the same thing for equation 2 and 3. Now let's see if it makes sense. Y now equals this. Y also equals that. So should this and that now be equal? Well, yeah. So we're going to set these two things equal. So I'm going to take 4x plus z and set it equal to x minus 3/2 z plus 3/2. So what I want to do now that I have them set equal is get my x's together and get my z's together. So when I get x over here, I'm going to subtract x. This will give me a 3x plus z equaling a negative 3/2 z plus 3/2. So again, I want to get x by itself now. So I'm going to move the z over here. So I'm going to subtract z from both sides. This will go away. I will have 3x over here. When I have 3/2 or 1.5, and I subtract another 1, I'm going to now have a negative 5/2 z plus 3/2. Now I should have done it back here. I should have gotten rid of my fractions. Now I have a whole bunch of fractions. Can I go ahead and get rid of them now? Sure. I want to multiply both sides of my equation by the least common denominator. Now that I'm here, my least common denominator is a 2. So I'm going to multiply both sides by 2. This turns into a 6x. Over here, when I multiply this, we get a negative 10. And then this is going to turn into a 3. Oh, I apologize. If I have 5/2 times 2, I'm just going to get a negative 5. My apologies. Now from here, again, we want to get x alone, so I'm going to divide through by 6. And it will tell me that x equals a negative 5/6 z plus 1/2. The 1/2 came from 3 divided by 6, and I reduced it down to 1/2. So now I have x all by itself, and x equals a negative 5/6 z plus 1/2. So I've set equations 1 and 2 equal, and that's what I got. I need to do the same thing for equation 2 and 3 now. We have an, oh, I'm using the wrong equations. We want to use these two over here, because these are the ones that we should set equal. So I'm going to take this side here, x minus 3/2 z plus 3/2, and set that equal to 1/3 x plus 2/3 z minus 19/3. Yeah, all these fractions. Definitely not going to forget to get rid of my fractions this time. I want to multiply this side and then this side by the same number, and I want to do it by the least common denominator. So between the 2 and the 3, the smallest denominator would be a 6. So I'm going to multiply through by 6. Here, that's going to give me a 6x minus 9z plus 9. Over here, when I multiply by 6, 1/3 of 6 is 2. 2/3 of 6 is 4. And this is going to give me a negative 38. So again, we want to combine our like terms. I want to get my x's together. So subtract 2x from both sides. This goes away. Over here I have 4x minus 9z plus 9 equaling 4z minus 38. I want to get my z's together, so I'm going to add 9z to both sides. This goes away. I have 4x plus 9. Over here, I'm going to get 13z minus 38. And I still want to get x by itself. I ran out of room, so I'm going to move it over here. To get x by itself, I need to get rid of the 9. So I'm going to subtract both sides by 9. I'm left with 4x equaling 13z minus 47. Now I almost have x by itself. I just have the 4 I need to get rid of. So I'm going to divide by 4 on both sides. This goes away. I have 13 over 4 here times z minus 47 over 4 there. So I've set equations 2 and 3 equal, and that gives me x equaling 13 over 4z minus 47 over 4. So now I've got step 2 done. Let's go on to step 3. Let's remember, I'm trying to get x, y, and z. Trying to find those. Haven't done it yet, so let's keep going. If I have x equaling this and x equaling that, shouldn't these two things be equal? Well, yeah. So let's set them equal. I'm going to take my negative 5 over 6, z, plus 1/2, and set that equal to 13 over 4z minus 47 over 4. So this is step 3. Now that I have these two things equal, I want to combine my terms. Notice I have just z. So if I can get z by itself, I'll know what it is. But I have fractions. I need to get rid of them. So I'm going to multiply through on both sides by my least common denominator. The smallest number that 6, 2, and 4 all go into is 12. So 12 times 5 over 6 is going to give me a negative 10. Then 12 times 1/2 is just 6. 12 times 13 over 4, that's going to give me 39. Then 12 times 47 over 4 is going to give me 141. Now I want to get my z's together still, so I'm going to subtract 39 from both sides. That goes away. Over here, I have a negative 49z plus 6 equaling a negative 141. From here, I need to get rid of the 6, so I'm going to subtract 6 from both sides. I get a negative 49z equaling a negative 147. Almost done. So negative 49z, negative 147. I divide, and z is 3. Yay, I found z. I still need to find x and y. However, now that I know z is 3, if I were to plug 3 in here, would I be able to find x? Sure. So let's do that. This is step 4. Find all the variables. So I'm going to take this equation, x equaling negative 5 over 6 times z now, which is 3, plus 1/2. This over here is going to give me x equaling a negative 5 over 2 plus 1 over 2. When I add them, I add the numerators because they have a common denominator. It's going to give me a negative 4 over 2, which is just a negative 2. So now I know x is a negative 2. I just have to find y. So, if you notice back up here, we have y, x, and z. I now know x and I know z, so I can plug them in to find y. So y equaling 4x plus z. I'm going to take my negative 2 in here, and my 3 here. Now I just evaluate. This gives me a negative 8 plus 3, or a negative 5. So I've gone through steps 1 was to get y by itself. Step 2, set these equal to each other. Step 3, find one variable by setting these two equal to each other. Step 4 is to then find all the other variables. So now we have x, y, and z, and we've